on my own web server for testing was good enough. So we will look into that actually. All right, so we're going to be talking about pesky n+1 queries and how to fix them. My name is Frederick Lawler. I've been working a long time. I work in databases all the time, and I do code for all the time and in my spare time. I do have social links up on the slides. This will be presented, or this will all be on GitHub as well, so feel free to download the repositories. And let's get started. So what are we talking about? In its most basic form, an n+1 query looks similar to this. We have a query statement, that's your +1, and then n more queries that we're running. So this is what we're actually going to be looking at tonight right here. And if this is confusing, just wait till we actually dive into the code. All right, so let's have a look at our system impact. So the reason why this is an important discussion to have, especially for newer developers, is because n+1 queries are extremely not performant for your applications. If you do not find them, your application will be slow. All right, so I have prepared a test project all in .NET Core C#. This will all be available on GitHub. And I've also set up a Docker container as well, so I'm going to go ahead and get my database going simply by running make run. Maybe not so simply calling make run. All right, should be ready to go. All right, so I'm going to go ahead and launch this. I'm going to open up PAW. Wait for it to build, give you my warnings. All right, so let's have a look at this query here. So I'm running an endpoint to grab all hotels. So I kind of made a database to model kind of like a hotel rooms, reservations, things like that. And we see here that I have 1,000 results returned, or 500, sorry, I forgot. So this is the query that I had to trim down because if I set it to the full 1,000 records I actually have, it does kill my server. So I had to trim it down to 500 records to display back. And we can see here that the total response time is 15 seconds. So that doesn't seem too slow, I guess, right? 15 seconds. I mean, for 500 records, but we can do a lot better. So with this simple switch of my dependency injection for the optimal solutions, we'll see how long it takes to pull back the full 1,000 records.
Hey Fred?
Yeah.
Sorry. Is this a local database?
Okay. This database is running on Docker, so...
15 seconds for 500 records then?
Yes.
Why?
We'll get to that.
Like it seems...
But it's not network latency necessarily. I mean, it's not off in the cloud or something.
No. This is yeah. Don't be fooled. Even though this is running Docker, even though I'm running Docker on this host machine, even if you're just running MySQL locally or anything like that, that's how much of an impact writing these sort of queries and this sort of code has on your performance.
We see the query?
We'll get to that.
Okay. Well, you were getting ready to change it and make it lower. So.
Well, I wanted to demonstrate the impact that we're going for here, the shock factor. So we're going to rerun this again at a full 1,000 records, 4.8 seconds.
Wait, can you do this for me real quick? Sorry, I'm so sorry. Because with .NET stuff, there's a little bit of a warm-up compile period.
Mm-hmm.
Can you rerun the query?
Oh, you're right. I may have cached it at that time. Sorry. Paul likes to cache request. Let's recompile it. All right, you want to do what now?
Run
Load
it a
it
few
and
times.
load it again. Yeah,
Oh.
load it a couple times. Just make sure the app is fully warmed up.
All right. wait, 9 seconds. Caching at that point, but
What did it get down to? 1.24?
well,
Okay.
well, that's the cache response. Remember, before uncached.
Oh, you're caching your data too?
Yeah, Paul likes to cache.
Oh, okay. I was just trying to get the overhead of Razor compiling and that kind of stuff.
Oh.
But that's, yeah, that's
Well, I mean, there is. We'll get to it.
okay.
We'll get to it. That's
That first hit after you run always.
well, I mean, technically, right now, PAW is caching the HTTP response. Therefore, it's pulling all that data and saying, okay, let's go ahead and spit it out faster. But that first hit did take 10 seconds or 15 seconds. The second hit took 4.8, so massive performance increase. Now that 15 seconds was only for 500 records and, well, their related entities. This one was only 4,000, yes. All right, let's get back to the slide here. Sorry, you're gonna have to bear with me on this one. Play from start, didn't mean to do that. All right, so we looked at the system impact. Now, there are very typical pattern, or there's a lot of typical patterns that kind of lead to imperformant applications, specifically involving n+1 queries. I've seen mangled data, or I've seen the data layer and the view layer kind of mangled together. Since there's a lot of looping involved with views or whatever, you can actually lead yourself into or down this rabbit hole of making these queries. Really, I should have titled this presentation, you know, don't loop your queries.
That wouldn't sound cool.
No, it surely doesn't. We're gonna look into Active Record. Is anyone here familiar with Active Record and its concepts? One, kind of. Okay, well, we'll look into that as well. And then the main reason why these problems kind of creep up and show themselves is through custom object graphs. If you don't know what if you don't know what an object graph is essentially we can look at the output of the JSON response, and we'll see that we have our records, and then within those records we have other individual objects. So in this case, it'll be hotel innkeepers and then hotel rooms as their own list of objects, and that's an object graph. Okay, so why don't we go ahead and look at those things. So I'm going to start with the active record approach. Well, actually, no, I take that back. Let's go ahead and look at what's actually going on with our in-performant code first, before we get into some solution, or before we get into the patterns that kind of lend itself to it. So, so I have created a very contrived repository here. Keep in mind that the code presented is not the best architecturally done. It's just meant to kind of show examples of what this might look like in your legacy projects, even. Specifically PHP projects. If anyone's worked with WordPress, you know what I mean. All right, so this is the actual function that's being called that has the most in-performant time. This is actually a pretty common pattern. We go ahead and grab my 500 hotels. For each of those hotels, I'm grabbing the hotel innkeeper and then the rooms. In my data model, I have it set up to where it's a many-to-many relationship, so there can be many innkeepers to a hotel, there can be many rooms to a hotel. So there's a couple of in-between tables to accommodate for that. And that's what we're building here. We're building an object graph. So for each of those hotels, loop through them, do another query, grab the innkeepers. For each of those innkeepers, grab the actual data, because we have that many-to-many table, so we have to first grab the relationships and then grab the individual, in this case, the individual innkeepers to pull back to attach to our many-to-many model. And for hotels, or for the rooms, I kept it pretty simple. Just grab all rooms that are associated with that with that particular hotel and not provide any specific details. So here's what we have going on here. We're pulling 500, running 500, or looping through those 500 records. We're doing a query, so that's one. For each of those, we don't know, so we'll just call that M. And then we're performing another query. So we have too many queries going on. For 1,000 hotels, this clearly would extrapolate to over 3,000 queries that we're running on a single page. Yikes. I have seen this in the wild. It is not fun. It's not fun to fix, not easy to fix, but easy to catch early on. And we can see that my queries aren't that complex either. Get innkeeper by ID, just grab the first or default, grab all the hotel rooms, simple enough. This is what we're looking for when we kind of dive into some of the common patterns, is we're looking for looping, gets, anything that kind of hints towards that we're working with databases. All right, so any questions so far on what we have going on here? No? All right, makes sense? Awesome. All right, let's look at Active Record. So for those of you who aren't familiar with Active Record is a certain style of ORM where you have your models that are actually reaching out to the database, pulling the data back. What I just showed you with the repository pattern is a separate idea from that, but Active Record kind of works in a different way, but you can do similar things with it. In this case, I created a user model, and what I'm trying to do here is I have an authentication service, and I have two endpoints that we might actually see in the wild here. One's to log in, and then one's to list all admin users. So in the Active Record style, we might try to first authenticate the user, grab them, check for if they have a specific role, and if they have a specific role, go ahead and do something with it. In my list admin users endpoint, I'm trying to grab all the users, checking to see if they have a role, and then again, do something if they have that. So I'm listing all the admin users in this case. But what's unclear is, where is this data coming from, and why is this a problem? The thing about Active Record is that it makes it really easy to write code really fast, but you might not realize they're actually performing queries behind the scenes. Right here, we're trying to grab here in this function has role, we're grabbing get roles, which, bam, performs a query. So you're looping. User by email address, again, another query. Get all, another query. So the nice thing about Active Record is that you can grab all your data in one spot, one model, hydrates the model for you, does all the ORM mappings and all these fun little things, but it's hidden. These function calls are hidden, and you don't know necessarily if you're actually making calls out to the database to pluck information. And when you do that, then you run into this problem, because you're building object graphs, you're making loops, you're making calls out to the database. I've seen this pattern a lot in WordPress. This pattern is definitely present in Ruby for sure. And CodeIgniter, that's another PHP framework that also has this pattern to it. So these are things to watch out for. Okay, so that's Active Record. Now, going back a little bit to that's the solutions. So going back to our hotels, you can see a lot of parallels between this and Active Record here. In code I work with, I see this pattern a lot because we make a lot of calls with stored procedures. Each stored procedure might turn back a result set, might return back one record. So we have this pattern a lot, and you might see this a lot too in your code. doing these get by IDs, get by whatever, So the trick is to, the thing is that those things are fine, but we can do better. So I'm going to switch gears back to our presentation. All right, so I know I didn't go into too much detail about mangling the data layer, but or the view layer, but I didn't have a chance to do that with MVC. So why don't we go ahead and look at query detection in projects. So I'd mentioned before that to create N+1 queries, you're going to see these common patterns throughout your code base. That's where you detect it in code reviews. Super critical. Now, the thing about code reviews is that this is your first line of defense to catch these right then and there. Because what happens often is that when you go back to your project much later, it's far more costly to fix. These are easy fixes. I know I haven't gotten to them yet, but bear with me. You'll hear complaints about slowness. That page that lists 1,000 hotels and their associated relationships. Contrived, yes, but you'll get people complaining about slowness. But what about profiling? So what if you don't actually know where in your application these things are coming from? It should be pretty trivial to open up any one of your APIs if you're building an API or any of your web pages and just hit a URL, and you should be able to see that it's probably going slow. But we can do better. We can actually see what's going on behind the hood. So I'm going to go ahead and demonstrate that. So part of my setup is I set up query profiling with Docker and MySQL. So whenever we hit an endpoint, we'll actually see the queries running behind the scenes. So I'm going to go ahead and switch the project back to its slow form, and then we'll switch it back to the optimal form, and we'll see the differences in queries happening there. I think this is the coolest part, watching the queries go down the page. All right, is it built? Still building? Okay. So I'm gonna go ahead and move this to the other screen real quick, and we'll go ahead and take a look at that. Nope. Oh no, it didn't spit them all out through the page. That's unfortunate. Well, at least we got one of the queries going. Let's go ahead and take a look at that again. All right. So here's what happened. There was more output, or there was more input into the profiler file than there was than it could actually spit out to me on screen. I'm not going to bother SSHing into this Docker container, but notice the difference between the queries here. Here we're looking for the, oh wait, no, that's the same. Huh. Maybe I should have tested this out. Oh yeah, I did, yeah. Okay, well, never mind then. I'm more familiar with SQL Server, and SQL Server has this profiling tool called SQL Profiler. It's actually a pretty nice tool. It will list out all the things for you. I'm not entirely sure why I can't get my profiler to show up all the output, but SQL Profiler will list it all out. I did do some research into looking for tools for MySQL, but I didn't really come up with anything too useful other than paid applications, or there was one that caught my eye called Jest, but I didn't feel like compiling it, so therefore I didn't demonstrate it. But anyway. Okay, well that's that then. Let's actually look at it the other way. We were only able to see the actual query that made the 500 call to grab all the hotels, unfortunately. I wish we could have seen all the other queries that are happening, but just imagine that there was more than 3,000 queries happening right there. So I'm going to go ahead and rebuild it. Alright, so now it's rebuilt. Go ahead and call that endpoint again. Alright, notice the difference in queries here. Instead of thousands of queries, I'm able to pull back those thousands of results in 2, plus all the relationships. So we'll be exploring next the different various solutions that kind of end up in this sort of result. But as a rule of thumb, your web pages, your applications, they should not be performing more than maybe like 10 queries, if that, right? You can do a lot with very little queries, and this is that demonstration right here where we have, it doesn't show the other, oh yeah, there's the other selects, nope, that's the other one. Dang, it's still not showing all the select statements. Oh well, anyway, so we'll go ahead and bring this out into a bit of a better view here. I don't know if that's necessarily any better, but so this is actually the second query that's ran. The first one would have grabbed all the hotels. This one is actually pulling in all the relationships. Notice how we have 2 joins here. So this is where it's grabbing all the relationships. Any framework is going to try to cache them, but a little bit more on that later. And that's how we're going to get our thousands of results, all of their relationships, super fast and quick. All right, so let's actually move on to solutions then. So solutions to this problem. Joins work, views work, and eager loading works. So let's actually take a look at why joins work for a moment. I've prepared some example code that I'm just going to copy and paste. I'm going to connect to my Docker container, and we're going to go ahead and run this. Sorry if you guys can't really see this too well, but all right, so this query is simple. We're grabbing the hotel name, the ID of the room, and the hotel room name. This should return back, as my notes specify, 190 records. Now, joins are great for simplified models, and I'll touch on that here in a minute, but joins are great for simplified models to where you take your relationships and you stretch them out. So instead of building an object graph, you have your data all flattened out, okay? The problem is that with joins, you have the additional problem of expansion, result set expansion, where that means duplicates can and will exist. Alternatively, you can still make 2 queries and reduce that. Now, in in this example here, we're actually returning back 187 records, and we're also doing another additional query. So we're not saving too much in terms of removing duplication in this particular example by only reducing it by 1 row. But it's easy to see that you can remove this duplication simply by doing more queries. All right, back to the optimizations. So looking at the optimizations repository, we're going to notice a few different things. First and foremost, I am using the Entity Framework ORM. Not active record, but it does do Object Relational Mapping, which is what active record also does. But in addition to that, it also formulates and builds queries. So the big takeaway here is eager loading your data. In all examples prior, we were not eager loading. In fact, if we have a look at the problems repository, we're actually doing lazy loading. Now, this code right here is actually called Explicit lazy loading. It's where you lazily pull in the data that you want. Active record works in this way. Or it can also be eager loaded, but I don't know the details on that. But in terms of ORMs, like in PHP land, we have Eloquent. Eloquent supports eager loading. I know for a fact. Most of them do. I know Doctrine does. Entity Framework does. Dapper is another ORM for C# that also works, but it's not as like feature rich as Entity Framework is. It's much more trimmed down. But the way it works is we're going to say, okay, I want to grab all my hotels. I want to include all the hotel innkeepers. So my model is set up such that the hotel innkeepers have this in-between table and it pulls in those innkeepers. Then I'm actually going to include the actual innkeeper data. And then lastly, pull in all the hotel rooms. And that's how we get those two queries that unfortunately did not show up in the profile earlier, but there are two queries. One that grabs all the hotels, and then the second query says, okay, with all those hotels, now perform these joins to bring in the data. But the nice thing about ORMs and particular Entity Framework is that it's going to cache all this stuff. So the reason why we may not necessarily want to do a join to flatten out our data, we might actually want to do two queries because we can actually utilize caching. So Entity Framework is going to try to pull back all the hotels. Those may not be cached. Cache them, pull in the innkeepers, cache them, pull in the relationships, cache them, and pull in the hotel rooms and cache them. So what this is great for is subsequent query calls, because now the ORM has all this data cached. Therefore, your performance is also increased because you're not making any more hits out to the database. So that's pretty cool stuff, actually. All this stuff, happens behind the scenes, and it's really cool to dive deep into, but that's unfortunately out of scope of this presentation. And then I have this other endpoint which just pulls in the hotel rooms, but it kind of works in a similar way. Given a specific hotel ID, go ahead and pull in all the room information that we could possibly want, and that's pretty much it for eager loading. It's actually a pretty powerful tool to be aware of and to use in your applications. But there is a caveat. If your ORM does not have a limit on the amount of depth in your object graph. Now, what this means is, like I said, object graph, you have your records and then your inner records, and all your relationships are kind of built out as some sort of like tree structure. If you do not have a limit on the depth of that, you can run into a situation where you can set up all your models such that they all eager load each other. Now, this is the worst case scenario, with one page request pulling in your entire database into your application. I've seen that, but fortunately, by limiting that, going into the code and using eager loading, using joins appropriately, I was able to reduce all that to where the whole database was not being pulled into the entire application per request. Yikes. All right. Okay, so so as I was mentioning with views, I did go ahead and put this specific query into a view, which is hotel room names. So again, the problem with views and stretching out this data is that you're not going to get that caching like you would with using eager loading, because if you think about it, you have to set up a special model for that specific instance, and when you do set up that model for that instance, what happens is all those get cached, but not the actual other models that you might use that go into the view. So for instance, with this join right here, I'm not going to get hotel rooms cached for me if I were to do subsequent calls. I may have the full query and all this data cached, but I won't actually have the hotel rooms cached because it's a different model. Benefit of splitting out your queries between two is that you can cache them. You can also map them manually. I did not demonstrate tonight on how to actually map data by hand and to perform this eager loading and etc. by hand. But that's how it can kind of all work together to do it by hand if you really need to, without the use of an ORM. Who's been there? Two of you? Wow, that's good. More than it's good that not more hands showed up for that one. All right. Okay, so we kind of looked at the solutions a little bit. Let's see here, going back to the slides. All right, so closing thoughts. Mike joked that this was going to take 9 hours to complete, but I'd say I worked pretty fast on that. So I'm hoping for a lot of questions because I did move fast and covered a great deal of things. Catch these problems early. It's super expensive to go back and fix them later. At work, there was a time where N+1 queries run rampant, right? And it took me weeks to undo all that to make the application run super quick. So if they're caught early, you fix them early, cheap, very effective. Use profiling. I'm sorry that my profile demonstration didn't exactly demonstrate the gravity of the situation, but use profiling. It's the best. Any kind of problem that you have with your database, you will find it with profiling. Joining is okay in some situations. Again, joining will flatten, and it will also expand your result set. So use them with views to simplify, but don't rely on them for caching and merging data together if you have subsequent recalls or subsequent database calls and queries happening in your controllers or service layers. Eager loading is good. Lazy loading can be good. Just want to throw that out there. But as you can see, it's very, very, very easy to run into an N+1 query situation with lazy loading. So get your data first, be done with it. I will be at Scotch and Soda if you guys want to have drunken arguments. But time for the good stuff. Yes?
So there's the wisdom in programming, avoid premature optimization.
Yes.
So if you're writing an application where there's going to be users frequently loading up the hotels, that's something where you say, yeah, we want to optimize that, as opposed to, say, a nightly process that goes through all hotels and does a cleanup job. In the latter situation, you might say, okay, 15-second operation is no problem. We're gonna favor speed of writing code and ease of understanding the code to optimization. Do you have any thoughts on that, or like anything to say to that wisdom of avoiding premature optimization?
Yes, I'm actually glad you brought that up. I actually had the pleasure of having coffee with someone a couple weeks ago when I visited Springfield. He brought up a good point. Writing N+ queries is wrong. Essentially, the way I see it is that you should always be writing performant queries, because the problem is if you think about it this way, now I know you're talking about background processes and things like that, but if you think about it this way, this was just for one request. Your servers are being hit multiple times, and it could easily take down a database with one of these things if done horribly wrong, right? For background jobs, I would say that it's probably okay to kind of deviate a little bit, but only for reference tables. If you have tables that have some sort of information that you want to reference and pull back in and do stuff with, I think it's okay, because you know those are going to be a small n no matter what. But I'm still going to lean towards the side of it's always incorrect to write incorrect code. So yeah, I would definitely lean towards trying to be as optimal as you can, because you never know. Databases always grow; they never get smaller. So
yeah. So another question / comment: when writing code, so like a profile.
yes,
If you're the developer sitting there, it's going to be pretty easy for you to pop that code open, profile it, make sure that you don't have 3,000 variables.
mm-hmm.
One or two. In a code review scenario, a lot of times when I've been doing code reviews, I'll have it pulled up in GitHub or Bitbucket, reading to the PR.
Mm-hmm.
Sometimes I'll say, oh, yeah, this looks good, I'm going to merge it, push it up the stage, or UAT environment. I'm not necessarily going to have the ease of running profiling and doing the same thing that in a development environment.
Right. So with code reviews, what you want to look for is for looping, where you might suspect that there's data coming in, because when you go into a code review, you already have some sort of idea of what that ticket or what that pull request or feature is trying to accomplish. If you know that there's a data aspect to it, you can easily go through the code and kind of find out well, maybe not easily in some situations, but you can go through the code and you can kind of pinpoint where there might be function calls that might lead to actual queries being ran on the database. When I code review, it's critical for me to actually inspect functions that I suspect that are pulling data from the database, because I do have developers that write loops often and pull data from the database. So I make sure I go in there and I kind of look to see where those functions are going, and I will follow those functions, even if they're not officially a part of the code review, like in the green. I'll still go through the code base and be like, oh, there's one, let's fix it.
So I think you make a good point that those things can be caught in code reviews.
Mm-hmm.
I work at Magento a lot. You have collections and you have individual items. And the newbie mistake is you grab a collection, you're moving through it, and you just hit load, assuming that, oh yeah, the ORM has a cache or it's already there. But no, a lot of times it's going to go and hit the database and do a brand new call.
Yeah, and that's what I was referring to as mangling your data layer with your view, because you're having your view make those calls for you. So yeah, exactly. Anything else? That's it? No more questions? I know Mike had a lot, but he's in the other room, so.
Well, I'll ask another one if no one else is.
All right.
Profiling, it's like an explicit action. You go and you look at the queries. Have you done much with like an application performance monitoring system, like New Relic, or anything like that, where you just kind of look at the entire application for these kinds of things?
I want to. I have not, though. Yeah, I mean, applications like that, I mean, so even if you're not directly, running profiling, those definitely would have some sort of aspect of profiling, and it'll definitely notify you, if a page is is taking too long to respond. Now, when I don't use those things, but I just know that whenever I hear a report of saying our page is loading too long or too slow, the first thing I do is I look at the database, because that is your bottleneck for your applications. So yeah, no, I wish I could use New Relic and all those fancy tools, but I have not yet.
Magento is a very heavy application, and it's not optimized, or if you write bad extensions for it, it's slowly down. So for a lot of our clients, we have New Relic APM, and it's the insights you can get through it are just amazing.
Yeah, WordPress has the same problem. If anyone's ever used Blade template Timber with WordPress before, no one. All right, well, oh, Blade, Laravel. Oh, did I say Laravel? I meant Timber's. Oh, I forget the name of that. Huh? Yeah, I know what I said. It was a mistake. Timber's like the plugin, but the actual template rendering system is called something else. And sorry I said Blade, I meant something else, but now I'm drawing a blank on it. But anyway, essentially, the cool thing about what Timber provides with whatever templating system that is, the cool thing about it is that it really allows your front-end developers to write their views, spit out code, because the way the templating system is set up is that it can make direct calls out to grab data as needed. So that's another example that is view and data layer mangling. Yeah.
.NET Core profilers on the Mac side?
Ooh, good question. I do not know.
I haven't used a good one on the Windows side in a long time.
SQL profiler.
C# profiler, so you can get similar.
Oh, you mean for actual .NET Core?
Yeah.
Okay, instead of just queries.
Yeah, so you can get similar output that will show you where you're spinning the loops,
Mm.
which will tell you what your queries are too, to a degree.
Oh, really? Nice. Very nice.
The one I used to use for Windows, it was EQA, TEC, Equitech, something. It's been years. I really only pull it out when something seems like it's wrong.
If it works for you. But yeah, I'm not familiar with that.
Query profiling, and you have application profiling.
Yeah.
So, yeah, well, then these tools, what you do is you compile it in. You basically, we fire up the tool, it'll take your output DLLs from your app, compile itself in, and then it'll run, basically it'll run through the application, and it'll spit out a profile. And
You get an entire call tree, you can see all that, like, dig in.
And it'll, you can break that in and say, okay, boom, here's one that's spinning up, and you can kind of dig down and say, oh yeah, here's 10,000 loops.
Yeah.
Yeah, I use, for at least JetBrains, PHP Storm in particular has an interesting profiler with Xdebug, with the Xdebug extension. But yeah, I mean, these all sound like great tools that I wish more people would use, for sure, because you know, it really does. I mean, it really does cost time and money when your applications are not running at their best. All right. Well, if that's it.
How many
Oh.
SQL in statement where you said you pull all these things where you know the value has this list of things, you know? How many lists, what's an effective number of list items you can pass into an inquiry without overloading the system? Does that make sense?
No, I know exactly what you're talking about.
Instead of pulling the full list,
Yeah.
I can run and iterate my IDs
Mm-hmm.
and pull back all of those items
Mm-hmm.
in a query.
Yeah. I didn't prepare any code examples, but I did want to kind of touch upon that. I found out that MySQL, at least the version I'm using, is not friendly with that. Because at least I'll speak in two terms here. SQL Server is what I primarily use at work, and then MySQL at past jobs and what I've been demonstrating with here. There is a limit. I don't know specifically what the limit is, but each server, MySQL or MSSQL, will say like, this is the maximum length of some sort of parameter string or varchar string you can pass into, like, say, a store procedure or anything like that. In MySQL, see, I tried toying with this earlier today. I tried two approaches, trying to pass in data, but I would try to avoid using string concatenation and having a huge list of IDs to just throw into something to pass in a query. But
On link to SQL, so you can easily write that query accidentally,
mm-hmm.
When you simply write an Entity Framework query and say, hey, where the ID contains, and then basically pop in your list of IDs.
Mm-hmm.
Right? So you may not be thinking of the SQL concatenation behind the scenes.
Well, in that case,
it's running the same kind of query.
in that case, it depends on the actual server, because what I was about to get to next is that in some cases the ORM might be able to try to optimize that by creating a table. Well, it may not in this case, because if the table value parameter may already exist, you can actually try to, in SQL Server, you can create an insert statement, insert in all your records, and then you can pass that table value parameter off to whatever kind of query you might want to run. Where exists select null from this temp table of sorts, and then where the IDs match, and then it has some sort of shortcuts and short circuiting to kind of pull back all your records. Now, in the case of MySQL, behind the scenes, I can imagine it taking a similar approach. I don't know for sure, but I would try to have, and I actually experimented with this earlier today, where I created a temporary table, okay, and then I inserted all my values into that, and then I did select on that temporary table, and then deleted the temporary table right afterwards. So I would hope that this ORM, I don't know for sure, but I would hope that this ORM would kind of take a similar approach, because doing string concatenations and things like that can get quite messy. But in the case of like a store procedure for MySQL, it would have to string concatenate all those things together. I think it's actually probably more performant to do a select, or to do a where from table, where the ID in select from the table as a sub-select, than it would be to try to put in all the IDs. But you can format your queries that way too, but it gets messy on the code to do that.
When you run your C# Entity Framework, or whatever it is, .include,
Mm-hmm.
what precisely is that doing behind the scenes? Is that making a join,
Mm-hmm.
or are you getting a separate cursor to another set of tables?
It's explicitly doing a join. So I know this is hard to see. Let me go ahead and format that real quick, so it's a little bit more readable. Bear with me here.
Yeah, there it is right there. So that's your include. It's causing a full join.
Yeah, so what's happening is that behind the scenes in this particular case, we are having the main query select all the hotels, and then we're joining all those and then all the associated data with it, and we're creating, Entity Framework behind the scenes is going to run this query to create this view for us that will have all the result sets for us, that it will then take and hydrate the models and perform caching on them, and then through the use of the IDs, in this particular case it'll be the hotel IDs, it will start to link all those behind the scenes in memory, so you have reduced memory usage, and yeah, just reduced memory usage, but all your data is cached that way and pulled that way. It's interesting that in this case that Entity Framework produced this sort of query. A few years ago, I recall that Entity Framework did not use joins, but that was for SQL Server, not for MySQL. So it kind of depends on what flavor of the ORM you're using to kind of build these queries. So you get kind of different results based off that. But yeah, it's actually pretty cool stuff.
Secretly, I knew about it. So you can see it.
Yeah.
Brendan, I don't know if you saw, so you were using the SQL profiler the other day, and in fact, you'll see what Entity Framework will do sometimes is some really pretty fat queries, right?
Yes, all the ones that it was posting out. It wasn't running the straight query, it was running it through the stored procedure first. It was like stored procedure execute query and then in string. And then it was a law
Yes, in that case, you said this was generated by Entity Framework. Yeah, so that tells me that the way I would do that, solve that particular problem, so it's not like a huge string of things that are being passed in, I would definitely try to create a table value parameter in SQL Server, and then do the insert, so insert all your values into that, and then pass that directly into the store procedure, so you're not having to rip apart the concatenation of all the strings in the actual store procedure, and you can select directly from that. I wish I had code examples for that, but cool. I know that's kind of like off topic though, but all right. Well, if that's it, then thank you. I'll be at Scotch and Soda. Clearly, I'm a nerd and I love talking about this stuff, so feel free to grab a drink.